Okay, I want to do just a few examples from the next worksheet because it kind of combines a lot of things that you have learned this week and the stuff that you hopefully remember a little bit from last year. Okay, but we're going to kind of put it all together. I'm going to do 3 examples here for you. First one is number 1 here, u to the 4th plus 2u squared. Every time I set out to factor a polynomial, the first thing I ask myself is if there is a greatest common factor, something that all the terms have in common. Is that the case here? Yeah. Yes. What do both terms have in common? U squared. So I'm going to bring a u squared out to the front. What would be left in the parentheses?
U squared plus 2.
U squared plus 2. Right? So that's just greatest common factor. Can I do anything more with the remaining factor that's in the parentheses? I cannot. If it was u squared minus 4, or u squared minus 1, or u squared minus 9, then I could do the difference of 2 squares and keep going with it. I can't do anything more than that. That one's done. Sometimes it's that simple. Sometimes all you got to do is pull out the greatest common factor. Okay? All right, nothing crazy there. Number 5. U to the 4th minus 4u squared minus 5. That's really no different than what you did yesterday on the second page where you were factoring trinomials. It looks a little different because it starts with the 4th power and then goes to the 2nd power and then goes to a constant. Okay? But it won't work any differently. This is a nice, simple trinomial. I call it nice because the leading coefficient is 1. Anytime the leading coefficient on a trinomial is 1, usually the factor is pretty nice for it. All you need to do is break it down into 2 binomials. What times what makes u to the 4th? U squared and u squared. And then what 2 numbers multiply to negative 5 but add to make negative 4?
4 and 1.
Or 5 and 1?
Or yeah, negative 5.
Which one's, yep, negative 5 and positive 1. That works, right? Because I got u to the 4th plus 1u squared minus 5u squared makes my negative 4u squared, and then I still got the minus 5 at the back end. Okay? So it works just like you did yesterday, except instead of starting with just x, now you might start with x squared and x squared, or x to the 3rd and x to the 3rd, that sort of thing. Okay? I look at them. I can't go any further with this. If that was a 4 or a 9 or a 16, any perfect square, then I could go further with this one. I can't go further with this one because it's plus. They're both perfect squares, but it's plus. I can't factor it any further. I'm done with number 5. Okay? Yeah?
Yep.
Keep going? Okay? All right. Number 10. This will probably pull back memory from last year. So number 10 here, there's no greatest common factor. There's nothing I can pull out of every term and write in the front in this case. It's a trinomial, just like this guy was a trinomial, but it's not a nice trinomial because it's got a leading coefficient of a number that's not 1. Okay? When that happens, what you were taught last year was to do a process called factoring by grouping. Here's what you would do. You would take the leading coefficient and you would multiply it by the constant. So you would take 7 times 30, which is 210. Then you would try to find 2 numbers that multiply to 210 and add to 41. So you try to find the pair of numbers that multiplies to 210 and adds to 41. Most people can't do that off the top of their head, so my suggestion is I make a list. 1 and 210. Those don't add to 41. 2 and 105. Those don't add to 41. 3 and 70. Nope. 4 does not go into it. 5 does 24, 42 times. 6 does 35 times. There's our winner, right? Those would be the 2 numbers that multiply to this and add to this. Okay? So that can be kind of challenging, especially when the numbers get big. Okay? Keep rolling. Any questions on that so far? So, here's what I do next then. Is I rewrite the original polynomial, but I rewrite it with 4 terms instead of 3. I rewrite the 41u squared as 6u squared plus 35u squared. I haven't changed anything, I just broke the 41 down into 6u squared plus 35u squared. And then you do what's called the grouping method, where you group the first 2 terms together, look at those, and you group the back 2 terms together and you look at those. When you look at the first 2 terms together, you ask yourself, what is my greatest common factor of those 2 terms? U squared. What's left?
7u squared plus 6.
Good, 7u squared plus 6. Then I do the same thing with the back group. What do they have in common? Positive 5. So I put plus 5. What's left?
6u squared.
7 u squared plus 6. If these don't end up the same, you goofed up. If these don't end up the same, you goofed. Okay? So now I can write my final answer. Both the u squared and the positive 5 are being multiplied by 7u squared plus 6. So my 2 factors are u squared plus 5 is one factor, and then whatever they got multiplied by in common is the other factor, the 7u squared plus 6. Plus, if you doubt yourself, distribute it back together. 7u to the 4th plus 6u squared plus 35u squared. And then plus 30. Okay? That's called factoring by grouping. I went through it pretty fast there. Real quick. 7 times 30. Take the leading coefficient times the constant, get that number. Find a pair of numbers that multiplies to that and adds to 41. Rewrite the polynomial as 4 terms, and then group them, pulling out the greatest common factor in each group. Yeah? You've seen it before?
Yep,
Remember like yesterday.
pretty well.
Uh-huh. Okay. Fair enough. Okay, so the rest of the day and into tomorrow, I just strongly recommend we just practice and drill the heck out of this factoring to make sure we're really good at it. It's going to make life easier the rest of the unit on polynomials. It's going to make you pass your focus area a lot easier on Summit. And again, it's a skill you need to have for upper level math classes.